Hi, welcome to our introductory video for SES FFT, for Fast Fourier Transform Tool for Transient Analysis. In this tutorial, you will learn how to create your first project. You will also learn how to run a forward analysis, which is decomposing a time domain signal into its frequency components. To start SES FFT, locate and double-click the SES software folder on your desktop. With your SES software folder open, find and open the Tools folder. Once in the Tools folder, look for the icon for the SES FFT app and double-click on it. The application will start. SES FFT will open on the Project Info panel. Here you can specify information about the case you'll be working on, or create a new file, open an existing file, or save the current file. For this video, we will be creating a new file, so just click on New. Once you have created a new project, the first screen that appears is that of the forward mode. From this screen, you can define the input signal of the system. For this example, we will use a Heidler lightning signal with a duration of 150 microseconds and with 2048 samples. The surge parameters are defined as 10,000 for the magnitude of the first strike and 5,000 for the second one. All time factors are set to 2 microseconds, except for time constant B2, which is set to 20 microseconds. Now that you have the parameters of your input signal defined, save the file to a folder of your preference and give the file a meaningful name. We will call this file My First FFT Model. Next, you click Compute Forward FFT in order to perform a forward operation. The time domain input signal will be decomposed into its frequency components, and some of these components will be recommended for system computations in the HiFREC computation module. Each step of the computation will be displayed in the Computation Trace panel. Once the computations are complete, the results will be saved in F09 and F27 files, which can be accessed by clicking on the corresponding buttons in the lower right of the screen. The F27 file contains the frequencies to be exported to HiFREC. The visual panels provide the wave shapes of the time domain signal and the frequency domain spectrum, which are updated in real time. By clicking on the Results tab near the lower left of the screen, you will have access to the GRAREP plotting options, where you can plot several quantities. By clicking on the Plot button, results will be plotted with GRAREP. This completes our forward analysis. Resulting recommended frequencies have to be imported in HiFREC. To do this, click on the Define tab and select Computation Settings to bring up the Edit Computation Data dialog box. Here, you can select the Multiple Frequencies option in order to introduce frequencies manually, or you may import the frequencies from the F27 file. Running the HiFREC computation module for this set of frequencies will allow you to perform an inverse simulation, which is to convert the frequency domain response into the time domain. The inverse analysis is shown in our next video. Thank you for watching this introductory video. We invite you to watch the second part, called Inverse Analysis. For additional information regarding SES FFT, we encourage you to check out our how-to manuals and our online help.